Well, good morning, good afternoon, good evening, wherever you're at, whenever you're watching this. Hope you're having a good day. I'm going to do a little bit of review now of some graphing techniques. Going to be working on how to graph polynomial functions. So these are the things you've spent a lot of time graphing in previous classes first here today, and then we'll take a look at some of the things that you have not graphed before and learn how to do those. So the constant function y equals k really isn't all that interesting. This would be, for example, maybe y equals -2. It's just a straight line side to side. Nothing really all that interesting about it. Now, when you come to a linear function, things start getting a little more interesting because you have a slope, so you have a rate of change. You have maybe a different y-intercept depending upon what you have. A line could go uphill, it could go downhill. We have all those types of things that are going on. So what we want to take a look at here is how do I make graphs of varying degrees based on these things? Well, a lot of it has to do with the end behavior, the way your ends are going. Okay? The idea is that if you have a positive slope, your line goes uphill. You always read a book from left to right. Well, the same thing with a graph. So reading from left to right, this line is going uphill. All right? So we've got a positive slope. A lot of graphs are going to act like positive lines. They're going to start low on the left, and they're going to continue up to the right. Now, if you have a negative slope, so add this to your notes, a line that were to go downhill. Okay, this is a negative slope. Well, again, what we're focusing on is what are these ends doing? We don't maybe know all that's happening in between, but we know with a negative slope that it starts over here on the left high and is headed downhill to the right. Okay? Now, anything with an odd exponent, an odd degree, is going to act like a line. It's either going to be positive, and it's going to start low and end high, and you're going to see all of that on the next page, or it's going to start high and end low. Okay? Now, let's talk about a parabola. A parabola and x squared. Things, again, start getting more interesting. All right? You have now a positive parabola where it opens up. You should know this from Integrated 2. Well, again, what we're focusing on is these ends, this end behavior, what's going on. Okay, and we're going to talk a lot about end behavior in class when you come together next week, Tuesday or Wednesday. So what's happening here is when I have a positive parabola, the parabola opens up, and you'll notice both of the tails here are going up. Whereas if you have a negative parabola, go ahead and draw that. If you have a negative parabola, both of the tails are going down. So anything with an even degree is going to act like a parabola. Okay? So again, we're going to be thinking odd degree, acting like a line. Degree is the exponent power, and we'll talk about that a little bit on the next page. And if it's an even degree, it's going to act like a parabola. All right, so let's turn the page. And up here at the top, I'm going to show you exactly what I'm talking about. All right? So, if I have a cubic function, now this is the, you get different looking cubic functions. I know we did like, half a parabola up, half a parabola down. Well, our cubic functions weren't all that interesting as maybe this is here. But the idea is that a cubic function is an x cubed, and that is an odd degree. Okay? Now, when I have an odd degree, it's going to act like a line. Okay, again, remember what I said. I said an even degree is going to act like a parabola. Now, if it is a cubic that is positive, it's going to act like a positive line, low to high. Notice how this one starts low here, does its thing, I don't know what its thing is, and then ends going up. It's like a line. That's positive. Okay, if this is a positive x cubed, it starts low, it ends high. Now, if you had a negative x cubed, so y equals negative x cubed, this would be one that acts like a negative line. So what's going to happen is that it's going to start high, do its thing, I don't know what its thing is, and then it's going to end low. See, what I'm talking about is these end values here, this end arrows, and again, it's going to act like a negative line. Okay, we're trying to figure out how these things start and end. We've got to figure out what happens in the middle, and that's what's coming later. But we've got to figure out, does it start high and end low, or does it start low and end high? Okay? Now, on to the fourth degree. Okay, so if you got a fourth degree, that's even. It's an x to the fourth power. All right? So the degree 4 is even. If it's positive, it's going to act like a parabola that opens up. If it is a negative even, so negative evens will act like parabolas that open down. So you'll notice this one acts like a parabola that opens up. Because a parabola that opens up, I'll draw it here on the picture, would start high over here, come down, do its thing, and then come back up and end high. So again, if it's even fourth degree, it's going to start high, do its thing, and then end high. Again, what we've got to figure out is what is its do its thing part of this. All right? Okay. Now, if it was y equals negative x to the fourth, some quartic equation, that's what you read that, some quartic equation that's negative, well, it would act like a negative parabola. This is what I'd be thinking in my mind. So it would start low, do its thing, whatever that is, and then it would have to end low. So that's going to bring into play like how many times it's got to cross the x-axis, okay, how many times it's got to loop around. These are things that we're going to have to look at, all right, and we'll be looking at those down here at the bottom. All right, now if it's fifth degree is odd degree. So which one is it going to act like? Is it going to act like a line, or is it going to act like a parabola? Well, because it's odd, remember it's going to act like a line. Okay? They either act like lines or parabolas. If it's a positive odd degree, it's going to start low, end high. And if it's a negative degree, it's going to start high, end low. So you'll notice this one was a positive x to the fifth, positive odd. It started low, did its thing, ended high. Just like a line that would be positive. Okay, you're gonna get the hang of this here as soon as we start doing some actual graphing. But you gotta get this basic information in your mind. Now, if it was y equals negative x to the fifth, this would act like a negative line. So I'm just kind of sketching it lightly there so you can see. So my x to the fifth would have to start high, do its thing. Maybe its thing is a couple of times, but it's got to end low. Okay, start high, end low. And again, we got to figure out what the do its thing is that we need to look at. Okay, and we will in just a minute. Now, global maximums and minimums. Global maximum and minimums, that would be these types of points. Okay, so if you had, so for global maximums and minimums, you'd have maybe this picture, let's say. Okay, it looks like this. This point here would be the global maximum because it's the absolute highest point on the entire graph. There is no other point in the whole world, think global, in the whole world, this is the highest point for that graph. In this whole graph, that's the highest point. That's what we're looking at. So it's the highest or lowest, and that's where I come up with maximum or minimum. The highest or lowest point on the graph in its entirety. So the entire graph, there is no other higher point. There is no other lower point. I mean, draw this picture. This would be considered a global minimum. Okay? That is the absolute lowest point. There is no other lower point. Now, sometimes in certain locations, there are maximums and minimums. So these are maximums and minimums, highest or lowest points in an interval. And an interval is a section of the graph. Okay, so in an interval, in a section, it would be your highest or lowest point. So let me draw you a picture of that. So let's say that you have this picture here. It comes up really high, and it comes up again, and it goes down. So if I look at only this section of the graph, just from here to here where I drew the pencil line, there is a maximum point in that section. There is a highest point in that section. It's not the highest point of the entire graph, though. This would be considered the highest point of the entire graph. So this is the highest point in this section. That is what we would call a local maximum, sometimes called relative maximums or minimums, because in that section it's the highest and lowest points. Now, good news is we don't really do much with maximums and minimums. If they come up, I'll give them to you, but there's some techniques for finding those that come up in later classes, but you need that information. All right, go ahead and take a little break, come back, and we will do the video now for actually how to graph, if I've given you intercept form, how to make those graphs. All right, so take a little break, and I'll see you in a few minutes.